Hello, welcome to today's math class. Here we have the question before us. Here the question is x to the power of 2 plus x to the power of 2 all over bracket of x plus 1 plus bracket all to the power of 2 equal to 3. Now, I saw this question somewhere, and actually the person that solved this math challenge used a very lengthy um, approach, and I said the time spent on solving this is just too much, and so I tried to manipulate it, in other words, using a different approach to conserve time to solve this challenge. And so I want you to use this approach instead, okay, in solving this math challenge. So, but at the end of the day, drop in the comment section if this method or this approach is okay, or you have any question with regard to the approach I want to use here, then leave it in the comment section, okay, so that we learn together. So let's go into today's challenge here without much waste of time. So we're taking our solution here, which is the first thing or the right thing to do in solving mathematics, okay? All right. So what we do here is this. Here we are having x to the power of 2, and the denominator here we are having it raised to the power of 2. So let's rewrite these 10 here now. Okay, so this can be written as our x to the power of 2 plus bracket our x all over x plus 1 plus bracket all to the power of 2 equal to 3. Okay, this does not change anything, right? Good. So with what we have here now, if I put in plus 0 here, doesn't make any difference, right? If I put here x plus 0, it doesn't make any difference. So I want to bring a system of addition that will actually give us 0 in that part. So I want to rewrite this numerator here. So this is going to give us x to the power of 2 plus bracket our x plus 1 minus 1 plus bracket all over our x plus 1. Everything to the power of 2 or equal to 3. All right. Now, if you look at this expression here, looking at this, from what I said earlier on, by putting plus 0 here, so plus 1 minus 1 will give us 0. So this has not really changed anything, right? Now, with what we have inside here, we can rewrite this expression inside here to give us another format. So let's go ahead and rewrite this. So this is going to give us s to the power of 2 plus bracket 1 minus 1 all over x plus 1 all to the power of 2. This is equal to 3. Let's look at this now. This is all over divisible 1. So if we find the LCM, this will give us x plus 1. And that is what we have here, right? So if we use divisible 1 here to divide this, it will give us x plus 1. So we use this one to times this x plus 1. That will give us x plus 1. Then minus this one here. So the denominator is already this. So we use the denominator to divide it to give us 1. And 1 times 1 will give us 1. So minus 1 here. Right? Good. So it shows that what we have in here is the same thing as this. This has not really changed anything again. All right. So we look again. We have to expand this using the binomial expansion. You remember the binomial expansion? Yeah. So it says that if you have your x there plus your y r to the power of 2, this will give us what? This x here will take x to the power of 2. Meanwhile, y will be y to the power of 0, which is 1. Okay. Then plus the power of x will reduce. And again, the coefficient is going to be 2. Okay, so this is going to give us x, and y will come into the system to the power of 1. So we have here y, then plus the coefficient here is going to be 1, then x will be raised to the power of 0, then y will be raised to the power of 2. So we have y squared. Okay, so from Pascal triangle, we know that this will give us 1, 1, 1, 1, 2, 2. Sorry, 1 here rather. So 1. So this is the first coefficient is 1, second one is this 2, and the third one is 1 here. So if we use this to expand this expression we have here now, what is it going to give us? Let's go gradually. So 1 is going to give us 1 to the power of 2, and this minus 1 all over s plus 1 is going to give us to the power of 0, so which is equivalent to 1. So let's keep that. We now have here plus the coefficient is going to give us here 2 into times 1 will now be to the power of 1. May y minus 1 all over x plus 1 will now be to the power of 1 also. So let's bring that into the system times our minus 1 all over x to x here, rather plus 1 all to the power of 1. Then the next term is going to be plus 1. We now take the power of 0, automatically we leave the system, and this, which is this minus 1 all over this, will now be to the power of 2. So I have here bracket our minus 1 all over our x plus 1 all to the power of 2. Get this? And so this power we have set this minus here. So it will turn to what? Plus. Then this minus we have set this plus here to now turn to what? Minus. So we can now rewrite this using binomial expansion to give us x to the power of 2. Then here plus. Okay, so let's put everything in bracket here. We're going to have here 1. Then this times this will give us here minus our 2 all over. Here we have x, then plus 1. Then this side will give us here plus. Here we have 1 all over our x plus 1. Put this in bracket or square. This is equal to 3. I believe there's no confusion here. Okay. So if we have this to be this, what is the next thing we do here? We can open up this expression we have here now. So let's open up this and now give us x to the power of 2 plus 1, then minus 2 all over x plus 1, then plus our 1 all over x plus 1 all to the power of 2. This is equal to 3. Okay, so let's forge ahead on this side of the bird. At this point, what do? We just have to add 1 to both sides of this equation. So let's go ahead and add 1 to both sides. So it's going to give us x to the power of 2 plus 1 plus 1. So we have plus 1 here already. Then minus our 2 all over our x plus 1. Then plus bracket 1 all over x plus 1 all to the power of 2 equal to 3 plus 1. So we now end up having x to the power of 2 plus 2, then minus 2 all over our x plus 1, then plus our bracket 1 all over x plus 1 all to the power of 2. This is equal to 4. This is all over divisible 1. So we can now use this, find the LCM of this and this. So this is going to give us x squared, then plus, yeah, let's draw everything here. We have x plus 1. So 1 divide this will give us this. So we use this 2 to times everything. So this is going to give us 2x, then plus our, will give us 2, then minus, here we have everything here divided this will give us 1. 1 times 2 will give us 2. Then plus our 1 all over x plus 1 all to the power of 2. This is equal to 4. So this leave the system. So we now left with x to the power of 2, then plus our 2x all over x plus 1. This is plus our 1 all over x plus 1 all to the power of 2. This is equal to 4. All right. So from this point, what do you observe? You discover that this will leave the system and we can bring this and this. So remember that while solving quadratic equation using the completing the square method. So this, we can add this and this. So this is going to give us x, then plus our 1 all over x plus 1 all to the power of 2. This is equal to our 4 here. So what do? We want to eliminate this. So we take the square root of both sides. So we then take the square root of this side, equally take the square root of this side, and introduce our plus minus. This radical goes with this. So we now have our x, then plus 1 all over our x plus 1, right? This is equal to our plus minus our 2. So we have two cases from here. Here the first one is going to take positive 2, and the second one will take negative 2. So let's take our case 1. So in our case 1, we're going to take the positive 1. So let's continue on this side and see what this gives us in turn. from here, we're taking our case 1, we have our x will now be plus 1 all over our x plus 1 equal to 2. So we eliminate this denominator, we multiply through. So this time this will give us x to the power of 2, then plus this time this will give us x, then plus 1 equal to 2 times this will give us 2x, then plus r2. Right? Good. So we can now collect our lighters, move this to this side, move this to this side. So this will now end up giving us x to the power of 2. If we move this to this, it turns to minus. So we have x minus 2x will give us minus x. We move this to this, it turns to 1 plus 1 minus 2 will give us minus 1 equal to 0. So this is a quadratic equation. We have to solve this quadratically, right? So we're going to use the formula method. So from our formula, we have our x now be equal to minus b plus minus the square root of our b squared minus 4ac, right? Everything all over 2a. So this is equal to, what is our b? Our b is minus 1. So we have this to be minus bracket minus 1 close bracket plus minus the square root of our minus 1 all to the power of 2 minus 4 times, what is our a? It's positive 1 times minus 1. Okay, let's put this in brackets so that you'll get misled, right? So we have this all over 2 times 1. So minus 1 times minus 1 will give us a plus 1. So we have here positive 1 plus minus the square root of, here we have 1, then minus 4 times 1 will give us 4 times minus 4 will give us plus 4. So this have to be reduced. Okay, so this is all over our 2 times 1, which is same thing as 2. All right, so let's continue here. Okay, let's see what this gives us in return. Now, if we add up this will now give us our x will now be equal to 1 plus, here we have the square root of 5 all over 2. So we have minus here. Okay. All right. So this is the value for our x1 and x2. So let's go down to look for our case 2. So from our case 2, we have case 2. We're going to have our s to the power of 2. Sorry, x, just x rather. So here we have x, that plus our 1 all over x plus 1 equal to our minus 2. So if we open up everything here, this is going to give us our x to the power of 2, plus our x plus 1 equal to minus 2x minus 2. Again, we collect our light and so move all the terms to this side of the equation. So this is going to give us x squared. Bring this to this is going to give us plus our 3x, then plus, bring this to this is going to give us plus 3 equal to 0. So let's erase this. So again, we use our quadratic formula, which is x is equal to minus b plus minus the square root of our b squared minus 4ac, right, all over 2a. So from here, what is our b? Look at our b. Our b is 3, so we have minus 3 plus minus, then the square root of our 3 to the power of 2, then minus 4 times our 1, then times our 3 again. So everything here all over 2 times 1. So we have this to be minus 3 plus minus the square root of, here we have 9 and minus 4 times 1 times 3 will give us 12. Everything all over 2. So let's continue here again. So if we subtract this, this is going to give us our x now be equal to, we have minus 3 plus minus the square root of 9. From this will give us minus 3 all over our 2. Now remember that our square of minus 1 is equal to iota. So we can bring iota to this because this is same thing as the square root of minus 1 times square root of 3. So this is going to give us here minus 3 plus minus, here we have iota into the square root of 3 all over 2. So we have our x3 and x4. So in all, we can go ahead to bring out the values of x that satisfy this equation. So we have our x1 is equal to, from our first answer, we have 1, then we have 1 plus the square root of 5 all over 2. Now x2, we have 1 minus the square root of 5 all over 2. The x3, we have our minus 3 plus iota. Okay, let's write the iota first. Iota root 3 all over 2. And our x4 is minus 3 minus iota square root of 3 all over 2. Oh my goodness. All right. So these are the 4 pairs or 4 roots to this challenge. All right. So this brings us to the end of this challenge. If you have any questions, I know there's a step in the process of solving that may spark a reaction. Just spot it out and drop your comments in that spot. Okay. What do you understand or what do you say about that? Okay. Is that manipulation okay? Is it right? Drop it in the comment section. If you like what has just happened here, drop a comment in the comment. Remember, this is Online Maths TV, and if you've not subscribed, do it to subscribe because here we release mathematical challenges, solutions to math challenges all the time for your learning, for your fun. I love you, and every one of us at Online Maths TV love you so much. And thanks for being there for us. Bye. Until we see you in our next class, do not forget to keep winning. Bye.